In this video, I am going to talk about Bernoulli differential equation. As you probably know, a Bernoulli differential equation has the following format: dy over dx plus p of x times y is equal to q of x times y to the power n, where n is not equal to 0 nor is it equal to 1. So if n is 0, this becomes a linear differential equation that should be solvable by integrating factor. If n is equal to 1, it becomes a separable equation which we can easily solve by separating the variables. In our case, by the way, n is equal to 2, which is the power of y on the right hand side. So I need to divide both sides of this equation by y square in order to solve this differential equation or Bernoulli differential equation. If I do that, I get 1 over y square dy over dx plus 4 over x times 1 over y is equal to x to the power 4 times sine of x. Now I'm going to make a small substitution, and that substitution will involve this. This is going to be my z. So if I assume z to be 1 over y, then my dz over dx is going to be negative y to the power negative 2 dy over dx. Upon further simplification, I'm going to get negative dz over dx is equal to 1 over y square times dy over dx. Now please note that this is the same as this. So I could say this is the same as negative dz over dx, or I'm substituting. So if I do the substitution, I get negative dz over dx, then plus 4 over x times z is equal to x to the power 4 sine of x. Multiply both sides by negative 1. That's going to give me dz over dx minus 4 over x times z is equal to negative x to the power 4 sine of x. Now, multiplying both sides by negative 1, that gives me a standard format for first order linear differential equation that I can solve, by the way, using the integrating factor. Integrating factor mu of x, as you know, mu of x is equal to e to the power integral p of x dx. P of x is the coefficient of z in this case. So it's going to be e to the power integral negative 4 times 1 over x dx, which is going to be e to the power negative 4 times ln of x, that is equal to e to the power ln of x to the power negative 4. I use the formula n times ln of x. N times ln of x is equal to ln of x to the power n. That's the formula I used. Now, here look, exponential and logarithmic functions, they are inverses of each other. So that's going to give you x to the power negative 4. So my mu of x is nothing but x to the power negative 4. Now I'm going to multiply both sides of this equation by x to the power negative 4. That will give me x to the power negative 4 dz over dx minus 4 over x times z times x to the power negative 4 is equal to negative sine of x, because x to the power positive 4 and x to the power negative 4, they're going to cancel each other out, give you just 1. So it's going to be sine of x. So the impact of multiplying both sides by the integrating factor is nothing but making the left hand side a derivative of the product of two functions. So in this case, the two functions are this: d over dx is going to be z times x to the power negative 4, and that is going to be equal to negative sine of x. Now I could go ahead and integrate both sides, by the way. Okay, I could go ahead and integrate both sides with respect to x. That's going to give me on the left hand side z times x to the power negative 4, and on the right hand side I'm going to get negative times negative cosine of x, right? The integral of sine of x is negative cosine of x plus some arbitrary constant c, and that's going to give me z x to the power negative 4 is equal to cosine of x plus c. Now to solve for z, I'm going to have to multiply both sides by x to the power 4, or equivalently divide both sides by x to the power negative 4. That's going to give me z is equal to x to the power 4 times cosine of x plus c times x to the power 4. But z is nothing but 1 over y, right? 1 over y right here. So this is going to be 1 over y is equal to x to the power 4 cosine of x plus c times x to the power 4, or y is equal to y of x, which is going to be equal to 1 over x to the power 4 cosine of x plus c times x to the power 4. And that, by the way, should be your solution to this Bernoulli differential equation. I hope that this discussion was helpful. Thank you very much.